Just like numbers 7 through 10, where we were converting polar to rectangular, here we're converting rectangular to polar. That means we can't have any x and we can't have any y. No more x, no more y in any of these equations because we want it to be only polar, so that would be only r and only theta. X squared plus y squared equals 81. X squared plus y squared is the same as r squared. So we can leave that alone. R squared is equal to 81. We can either leave it, so let me back up. When we solve or convert to polar, we want to keep either solve for r, so keep an r by itself on one side, or just an r squared on one side. Either one would be fine. So again, we're going to separate the r's and the thetas. For number 12, we've already done this one. Number 9 and number 12 are identical, but they go in the different directions. But if y equals -5, if you want to convert that to polar, we know that y is equal to r times the sine of theta, and r times the sine of theta equals -5. And again, we want to separate the r from the theta on either side of the equal sign. So we're going to divide both sides by the sine of theta, and we can leave it like that, meaning -5 over the sine of theta. We can leave it alone, or you can write it as -5 times the cosecant of theta in the way it was written in problem number 9. So we'll leave that alone, we'll leave that alone, and let's look at number 13. So number 13 is a straight conversion here. Y squared, we know that y is r sine theta, so we're going to square that, and we know that x is r cosine theta. So we're going to go ahead and get rid of these parentheses. We're going to square the r and square the sine of theta. And we're going to get rid of these parentheses as well. And what I said was we want to separate the r's from the theta. So we're going to divide both sides by r. We're also going to divide both sides by the sine squared of theta. And in doing that, we see that one of these r's cancels, and that's okay. We get r equals, these r's cancel, we get 10 cosine theta over sine theta. Let me write it like this. So let me write it like this so it makes it a little bit easier to see. So we're going to separate that sine of theta in that way. And so that we can write it like this. 10 cosine theta over sine theta, that's cotangent theta. 1 over sine theta is cosecant theta. And maybe that would be an easier way to write it. But really, if you left it alone as cosine over sine squared, that's not the end of the world. And in fact, that would be okay as well. For number 14, straight substitution here. X is equal to r cosine theta. Y is equal to r times the sine of theta. And that's all equal to 7. Gathering the r terms on the left side, we're going to separate this. We're going to write this as r squared. R times r is r squared. And then we have a 3 times the cosine of theta times the sine of theta, all equal to 7. So we're just going to divide both sides by 3 cosine theta sine theta. And we separated the r and the theta. We have no x, no y, and we're done.